So we have that a telephone company representative estimates that more than 55% of its customers have call waiting service. To test this hypothesis, she selected a sample of 500 customers and found that 59% had call waiting. At alpha equals 0.10, is there enough evidence to support the claim? Use the critical value method. So let's write the claim in symbolic form. What's the claim? That the proportion is what? The proportion of customers with call waiting service. Is it equal, not equal, greater than, less than? It says that it's more than 55%. So the claim is that the proportion of people with call waiting service is greater than 0.55. Remember, we convert the percentage into a decimal by dividing by 100. So if the claim is P greater than 0.55, where do we write it? In the null hypothesis or in the alternative hypothesis? In the alternative, because in the null hypothesis, we can only put the equal sign. So in this case, the claim is in the alternative hypothesis. And then what will be the null hypothesis? What's the only symbol that we can use in the null hypothesis? That P is equal to 0.55. So that's the first step. We identify the claim, we write it in symbolic form, and then we state the hypothesis, the null hypothesis, and the alternative. So what type of test is this? Left tail, right tail, or two tail? This is a right tail test because we are using the greater than symbol in the alternative. So in the second step, to find the critical values, you need to know what type of test is, because depending on the type of test, you need to find one critical value or two critical values, and also depending on the type of test, the critical value will be positive or negative. So in this case, since we have a right tail test, do we need to find one critical value or two critical values? Only one. And is the critical value positive or negative? It will be positive, very good, because the critical region, the rejection region, will be the area to the right of the critical value. So this number will be positive. It's to the right of 0, the center is 0. So what's the value of alpha that we're going to use in table F? 0.10. So let's go to table F. Alpha is 0.10. Now, where do we look for 0.10? Where it says one tail alpha or where it says two tails alpha? This is a one tail test. So, because left or right will be one tail test. And two tail is the only one that we use this row. So one tail alpha 0.10 is here. Can you see last row? So what will be the critical value? 1.282. So this number here is 1.282. Positive because it's a right tail test. What will be the next step? Now we find the test value, we use the formula. So far we haven't used the information in the sample, so now we need to use the sample to find the test value. So first we need the value of p hat. The sample proportion. What's the proportion in the sample of customers that have call waiting service? 0.59, because 59% of customers in the sample have call waiting service. So in decimals, that's 0.59. So this is the value for p hat, 0.59. Minus, what's the value of p in the null hypothesis? .55. So that's the number that we're going to subtract. Then we're going to divide by the square root of 0.55 times Q. What's the value of Q? 0.45 is 1 minus P. So 1 minus 0.55 is 0.45. And then we divide by the sample size, 500. So use your calculator, 0.59 minus 0.55, enter, division, square root of 0.55 times 0.45 divided by 500. So you should get 1.798. Usually we're going to round to 2 or 3 decimals, the test value, because we're going to compare it with the critical value. So where does this test value fall? In the rejection region or in the non-rejection region? In the rejection region. In this right tail test, the rejection region is the area to the right of the critical value. So the area to the right of 1.282. So 1.798 is greater than 1.282. So the test value falls in the rejection region. So what's the decision? Reject or fail to reject? We're going to reject the null hypothesis because the test value, the sample, is telling us to reject because the test value falls in the rejection region. 1.798 is to the right of 1.282. So now based on the decision, let's write the conclusion. So we decide to reject this hypothesis. We can reject it. So if we reject the null hypothesis, can we support the alternative? Yes. When we reject this hypothesis, it means that we can support the alternative. And in this case, the alternative hypothesis is the claim. So what will be the answer? Is there enough evidence to support the claim? Yes or no? Can we support the claim? Yes. Okay, because we reject that P is equal to 0.55, so we can support the alternative that P is greater than 0.55. So there is enough evidence to support the claim. That the proportion is greater than 0.55. We can support the claim of the company representative. So you have the answer for this problem also in the slides. The critical value, the test value. The test value falls in the rejection region, so the decision will be reject the null hypothesis. And then we say that there is enough evidence to reject the null hypothesis, so we can support the claim that more than 55% of the customers have call waiting service.